page of our summer packet. So you should be looking at page 2. Problem 3 starts with everyone's favorites, logs, right? So the most important thing for you to remember about logs.
I think that is on the head up here somewhere.
Yeah.
Logs really are exponents, right? So here, the things that you need to, for calculus, think about logs is, again, for multiple choice. After you do a bunch of calculus, you could get down to this as your answer, and there's no logs in the choices, right? So you need to be able to simplify, which, remember, simplify means that you're simply rewriting.
Yeah. Oh, that's it, maybe? Yeah, that's it there.
You're just rewriting. You're not changing anything. You're not solving anything. You're just rewriting. So logs is a fancy word for exponent, and what this is asking for is what exponent
I see the road.
Yes.
Is it art museum?
What's that?
What is it?
Art museum. So you park.
turns that little teeny number.
And then you take a train, basically.
Oh, that's pretty sweet. So the
So
art
the
is
log
cool,
word
but the
is
museum's
says
even
what
cooler.
exponent
It's really the ground thing. It's just on the other side. It's close.
turns
Seven.
to
Somewhat nice location.
And so you see the light. So yeah. So
into 8. So in other words, you want to think of this as log base 2 of 8 is saying what exponent turns 2 into 8. 2 to the what is 8. 2 cubed is 8, right?
Yeah, you hand me those pretzels.
Therefore,
They're on the
the
floor.
exponent that turns 2 into 8
Thank you, kind sir.
is 3. Because 2 cubed is 8. Another way to think about this is take the 8 and see, is there any way I can rewrite this with a base of 2? So the exponent that turns 2 into 2 to the third is 3. Logs are exponents. So the reason I showed you that is because for this problem, this looks confusing. Firstly, where the heck is the little teeny number? So let me remind you that when I write the letter X, and I asked you, what is the exponent on that? You say 1, don't you? Because an exponent of 1 is so common. If you do not see a base, it's because they're using the most common base. If you see no base, it means that the base is the common base, and the common base is how many fingers and toes do you have? Base 10. Much of our world is in base 10, right? So I'm going to rewrite problem B this way. The exponent that turns 10 into 1 over 100. Well, that's still a little confusing. How about I use a little middle school math? The exponent that turns 10 into 1 over 10 did there? Since logs are exponents, try to always get this piece. Think about what kind of exponent can go with that piece. Oh, that's 10 squared. Well, wait a second, that's still an exponent, but it's in a denominator. So what if I do this? The exponent that turns 10 into, what did I tell you about exponents that are in denominators or numerators? Can't you move them? Move the base to the numerator, change the sign on the exponent. Now answer the question. What is the exponent? What is the exponent that turns 10 into 10 to the negative 2? Logs are exponents. So this answer is negative 2. So again, what's going to happen with these on your AP exam is that you're going to do calculus that doesn't look like it has any logs in it. You're going to have to use logs to get to the answer. You're going to get an answer that looks like log of 1 to the 1 over log of 1 over 100, and then you're going to look at your 5 multiple choice answers, and negative 2 is going to be there. And you need to understand very quickly that this is the same as negative 2. So notice this problem had a base 2. This had no base, and I told you it's a common base. This has no base either. ln stands for the log, that's where the L comes in, of the natural number. Do you know what the natural number is? E. Pretty interesting about E is, do this first, the log of the natural number, ln. So before I do C, if I say ln of 2 is actually the same thing as the log, the exponent that turns base E into 2. Now, E is an irrational number, right? So it's kind of funny that it's called the natural number, because the natural number is E, and E is approximately
It's more to say a cop
a little
going
bit
over,
smaller
right?
than 3. So it's 2.7.
It's more of a cop, so you can't do that.
It's irrational, so it doesn't terminate, right? And it doesn't repeat.
Oh, guess who's about to do it?
Right? Really, all you have to remember is that E is a little bit smaller than 3. But if you want to geek out, it's 2.7. 1828 is when Andrew Jackson was president. 1828 was when Andrew Jackson was president. And 45 degrees, 90 degrees, and 45 degrees is how my window wiper in my grandfather's car used to click, because he didn't have intermittent window wipers. It would click at 45 degrees, 90, and 45 degrees, and it was super annoying. But you couldn't say anything because my grandfather was a very mean man, so you had to just shut up and be annoyed with it in the backseat. Anyway, you know another a very famous irrational number, right, called pi. Pi is an irrational number, and it is approximately a little bit bigger than 3, right? It's 3.1, right, so a little bit bigger than 3. And then, I don't know, how many digits do you know past there? I have to say, I don't geek out about this one. 3.1, 4, 1, 5, 9, da 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 da. I don't have any cool thing for that. There are lots of irrational numbers, right? These two irrational numbers, of all the irrational numbers, these two come up a lot in math. So a guy named Euler decided to give them a name somewhere around the 1400s or so. And he just, pi was one of his favorite numbers in the Greek alphabet. And so he said, let's call this circumference of a diameter of a circle to its circumference pi, the Greek letter pi. And everybody said, cool, okay. And then E was another number that occurred naturally in mathematics, just hasn't occurred naturally to you yet, but guess when it will? When you take calculus. Anyhow, he decided to name it after himself. So Leonhard Euler, his last name starts with an E. So that's why he got the name the natural number after himself. Pretty cool, huh? He didn't discover E, but he came up with a lot of our notation. So anyway, back to problem C. So look at this problem. So again, before I do this problem, I want to go back to the problems that we had before. And what if I said to you, what is the exponent that turns 10 into 1,000? It's the exponent that takes a base of 10 and turns it into 1,000. Isn't that 3? What is the exponent that takes 5 and turns it into 25? Isn't that logs are exponents? That exponent is 2. What is the exponent that turns 4 into 16? Notice what I did there? This time I wrote 16, but isn't 16 actually saying what is the exponent that turns 4 into 4 squared? Isn't that also 2? So look at this problem. E is irrational, so I don't know what E times E times E is, but look at what this is saying to you. This is saying, and let's take that ln notation out of there. What is the exponent that turns base? What is the base for ln? E. What is the exponent that turns E into e to the 7th? Well, what are logs again? Logs are exponents, so this answer is 7. Pretty cool, huh? And again, I'm not asking that you, right, know every single, when you took Algebra 2 and you do pre-cal, you learned a lot of log properties and a lot of log situations. The AP Calculus test is not a log test, but there are a number of problems that you'll do calculus for, and you're going to have to work with logs in the middle and be able to evaluate the answers, right? So the purpose of us putting these problems into the summer packet was for 50% of that test that is multiple choice, and we want you're going to have to spend time on the calculus. I don't want you to have to spend time figuring out that log base 2 of 8 is actually the 3. So if this is a big deal for you and you're like, I have no freaking clue what she's talking about, on your list, remember I talked about your list of worries, right? From the first video, you had factoring, and difference of two perfect squares, right, were the things that we had on the first page, and we had fraction work on the first page. Right, we had fractions, common denominators to combine, and then division. Remember, using division is the same as multiplication of the reciprocal. We had to practice that. Exponent rules. And today we are going to add, so far, log rules. Okay? So look at the next group. Which one of these problems is a log problem? only the middle one, right? This is a log problem. So this is the log of the natural number, so you want to think of this. The log of the natural number means what is the exponent that turns e into 1? So another thing you can think to yourself is e to the what is 1? Well, this actually leads into exponent rules now, doesn't it? What exponent turns any base into 1? Right? Isn't it true that 3 to the 0 is 1? 17.6 to the 0 is 1. Do we remember why that is? You remember our exponent rules that I reviewed in the last video. Do you remember, for example, when you had x to the 5th over x cubed, right? That's 1, 2, 3, 4, 5 x's over 1, 2, 3, and x divided by x is 1, x divided by x is 1, x divided by x is 1, and you got x squared. And x squared is the same thing as if you said see the base twice with division in between, write the base once, and subtract the exponents, right? Well, what if you had x to the 5th over x to the 5th? Isn't anything over itself, other than 0, of course, equal to 1? But following the rules, the exponent rules, that has to be x to the 5 minus 5, which is equal to x to the 0, which we've already decided has to be 1. So, of course, x can stand for anything other than 0. That's a little bit of foreshadowing. So if x is 3, 3 to the 0 is 1. If x is e, e to the 0 is 1. So what is the exponent that turns e into 1? Well, that's 0. Crazy, whack, funky, huh? So look at f. What is that? I don't care to the 0 power is equal to 1. Now again, foreshadowing. I've already given you one clue in the last video. You always learn that anything over itself is equal to 1. I don't know about 0 over 0. I also learned that anything to the 0 power is equal to 1, unless it's 0 to the 0 power. I'm not sure. No one ever told you about that in algebra or pre-cal, right? These are things that we will start to investigate in calculus. They're unknowns. Zero is a very special number, and we're just not sure what really happens with them. So you don't have to worry about that now. I'm just giving you a little, again, foreshadowing of something that we're going to talk about in calculus, is the investigation of 0 and infinity. Kind of crazy. All right. Enough foreshadowing. So, this was a log problem. This was an exponent problem, but it was a special one because it was a base. It was 2.7-ish raised to the 0, which was 1. This is an integer raised to a fractional power. When you first are in Algebra 1, you don't deal with fractional powers, right? They teach you exponents, but your exponents are always positive at first and then negative. Teach you about negative and then 0, right? But what happens when you have a fractional exponent? Again, if you do a bunch of calculus and you get down to this answer on the multiple choice part, Again, this simplification practice was all for the multiple choice part of the free response. I'm sorry, of the AP exam. This answer will not be there. You have to know the radical rules, and you have to know that 27 to a fractional power is actually a radical. And it is a radical where the denominator is in here, and the numerator can either be on the inside, or it usually is easier on your brain to be on the outside. And again, this is for multiple choice, non-calculator. If I have a calculator, what do I care? 27 to 2/3, I punch it in my calculator and I get a decimal approximation. But half of the multiple choice
So
problems
Dean, take the 105
are
is what it's
without
telling me.
a calculator. So you have to know mentally
105 goes over
how
to
to
5.
do this.
Otherwise, I have to take
So
on tolls.
what number can you multiply 3 times together to get 27? It ain't 2, is it? 2 times 2 times 2 is 8. But what
Or
is
you get
3
off the
times
405
3 times 3?
later at some point.
Working inside
Yeah, this
out,
doesn't have it. You
the
do it.
cube root of
Does yours
27
have
is 3,
105?
and now what is 3 squared?
Yeah, or keep going on the 405.
Mine has us keep going on the 405.
Okay?
Yeah.
If you don't
It just
believe
says
me,
tolls. I
go
thought
to
it
your
was letting you go,
calculator
Mike.
That's just the
and
7.
type in 27
That's later.
That's later.
Gotcha.
to the 2/3,
So
and
from
you're
the
going to get 9.
405, you can later split to the
Right? So
see.
you do have
Gotcha.
to know
Which
how
is
to
the
deal with
total.
fractional power.
Gotcha.
So in that
405
list of
itself,
things
which
to
is
worry
fine,
about,
runs right back
your
to the-
exponent rules,
Eventually,
You
I
need to
don't have to
know
like this. I
how
can
to
just
deal with
it'll
fractional
merge.
powers.
It literally runs
So
up.
again,
Gotcha.
let
All
me
right.
reassure you, half of the AP exam is you writing out answers. When you write out an answer, which is not multiple choice, they don't care if you simplify, right? You don't have to simplify any final answer at all. But on multiple choice, and especially on the multiple choice that doesn't have a calculator, you're going to have to know quickly what 27 to the 2/3 is. And not knowing it quickly doesn't mean you'll fail the AP exam. It'll just slow you down, and maybe is that difference between the 4 and the 5 or the 3 and the 4, right? So this is within your control to practice before you take that exam. It is just rules. It's like doing sit-ups at the gym. So just do it, right? NBD, no big deal. All right. Now, what I want you to notice is in your directions is not simplify, is solve. So solving is not rewriting. Solving means you are finding an answer, and you best make sure it works. This part is not always necessary. This is necessary, Jeff, if it works, if your answer is a number. So notice here, they are just asking me to solve for z. This is not the same kind of solving like when I solve a quadratic and get x equals 2. This particular solve is just asking me to unpack z. Z has got all kinds of crap happening to it, and they want me to isolate z. Now, this is not for simplification or for multiple choice. When you are next year in calculus, you are going to need this skill in something called implicit differentiation. Which is in unit 4. And it's not going to quite look like this. It's going to look different. It's going to have some calculus stuff in it. But you're going to need to find one thing inside an equation, and you're going to have to isolate it and get it by itself. That thing is going to be a derivative. You don't have to worry about that now. So for your summer packet, we just gave you practice like they do in Algebra 1 and Algebra 2. Here's an equation for no reason, really, other than what we need you to do way up in calculus. I need you to get z by itself. So this is a practice in the order of operations backwards. So remember the order of operations, right? For before MCPS got a hold of us, we had to say, we used to say, please excuse my dear Aunt Sally, right? And then MCPS said, don't teach them acronyms. Well, I still do, right? You take care of what's in grouping symbols, parentheses, radicals, brackets. Then you take care of exponents. Then you do multiplication and division in the order they appear from left and right. And then you do addition and subtraction in the order they appear from left to right. That's how you evaluate. But to solve, you do the order of operations backwards. You go the other way. You get rid of all addition and subtraction, then you get rid of multiplication and division, then you get rid of exponents and rid of grouping symbols. So when I want to solve for z, I need to get rid of all addition and subtraction first. So I'm going to move this -3 to the other side, make it a +3, and I'm going to move this 4x to the other side, change its sign, make a -4x. Now I'm going to, so I did that, check, I'm going to get rid of all multiplication and division. I only have multiplication here. So I'm going to undo the 10y by dividing by 10y. Now, you are done at this point. But what if that answer isn't there? Here's some other ways. You get full credit for this answer. But what if, again, you're on multiple choice and the answer looks like this? Would you still recognize it? Or what about this situation? 3 has no common factors with 10 or y, but notice that 4 and 10, whoops, that's supposed to be just a minus, have a common factor of 2. So would you recognize that this blue and this blue and this red are all equivalent expressions, which means AP can choose one of these, not 2 of them, but if you were doing multiple choice, they could choose any one of these forms, and you just have to have practiced enough that you recognize those are all the same thing. Here's another way I could write it. I could use, right, the commutative property up on the numerator and put the -4x first and the +3 second. I could have put the y in front of the 10 too, right? So again, if you're writing the answer, which is 50% of the AP exam, you can just leave it the way you want it as long as it's right. But if you're matching multiple choice, you have to have practiced the skill that you can mentally look at an answer and see 5 different ways that it might be right, that it could be written, and match that to a multiple choice answer. So let's try this one. Firstly, I've got to find my, oh crap. I've got Z here, and I've got Z here. Oh, ugh. Alright, well, let's not panic. Let's get rid of, right, keep the blue boxes on the left side and move everybody else off to the right.
I think we're far enough south now that
Yep, I'm tooling in on a gas station.
see one close on.
I'm going to move the 4x, which is negative,
I
over
got
to
one
the other
coming up.
side, so it'll be positive. I'm going to move the y squared over to the other side. It was positive, so it'll now be negative. Ugh. I've got a situation here, right? My situation is I've got a z in 2 places. places, and I need the z to only be in one place like it is here. Hold on, what's that? Who do I hear? Is somebody knocking at the door? No, not knocking. But I see somebody at the window. Who is it? It's factoring! Factoring always comes to the rescue. What happens if you take this z and pull it outside the room? Put the z out front. If you take the z out of 3yz, who's left? Take the z out of 8z, and who's left? That minus and the 8, right? If you don't believe me, multiply it back, and don't you get the same expression? Now, remember, who do I want by itself? What is happening to z? Z is being multiplied by that room. How do you undo multiplication? Right? Woohoo! Now again, there's a whole bunch of different ways I could write that. Don't you dare cancel this y with a y squared up there. You can only do that if you have factors and you have a minus sign here. But I could use the commutative property. I could split up both of these fractions, right? I could write this as 4x over 3y, right? And minus y squared over 8 plus negative y squared over negative 8. Right? So there's a whole bunch of different ways I can do this. Now, I should also say, by the by, y can't be 0 here. By the by, y can't be 8/3 over here, because then I get 0. Generally, you don't need to do that when you are just solving for a variable. Alright, switching gears here, and also there is a typo. This is f of x.
What side? Which side?
So,
It says
given
on the
3 functions,
Right side.
1
You know that trick
Two.
on the gas gauge?
and 3 functions,
Ah,
there are
I've
4
never
things that
not
I'm
thought of
asking
that.
you to do.
I did not know that trick. It's good to know.
Yeah, most cars
Now,
have
before I start, just
2005-ish
looking at this
have
globally,
that.
I want you to notice that
Camry
those
is
2
too old.
problems mean that
Camry's
my
too old.
answer is going to be in terms of x. But these 2 answers are going to be numerical. So they are asking me to find or evaluate. But when you are just given everything in terms of a variable, you're going to have variables in your answer. So each one of these problems on my list of worries, composition. Something you did in Algebra 2 and Pre-Cal, composition is an operation that you can do with functions. We don't have we can add functions, subtract functions, multiply functions, divide functions, just like we can with numbers. We don't do composition with numbers, but we do composition with functions. So, to refresh your memory, let me ask you that if I gave you this notation, which by the way comes from Euler, if I said h of 1, do you know what that means to do? Yes, of course you do. It means go find the function h. That's not function 1, because that's f. It's not function 2, that's g. It's function 3. And instead of the x, you're going to put 1. So h of 1 is 1 squared plus 5, and that number is 6. in this function called h, when you replace x with 1, you get an answer or a range of 6. So try to think of, instead of the 1, they're putting another function into h.
I got need. No.
Gonna fight?
Oh, here. Let's take hop in, but I'll take
So
it. Oh, well.
Too slow.
notice when h is 1,
We have plenty of gas.
I
you can buy.
replaced
Can you
x
throw
with
this
1.
away at least?
Yeah.
Well, up here,
This nasty thing's been in the
they're
car
not
forever.
asking me to replace x with 1. They're asking me to replace x with an entire other function.
Oh, it's just open. It's just on the top.
So h of g of x equals x squared plus 5. But what is g of x? Can you find what g of x is called? There's g of x's other name. So in place of x, put g. And bam, you have just completed composition. What you haven't done is simplified the expression, which again is fine, except this answer is not going to be in multiple choice. The square root of something squared is itself. So h of g of x is x plus 2. Crazy, right? Composition is putting one function into another one. Now, this problem is not all the way done, but I'm not going to finish problem A yet. I'm going to come back to finish it, okay? Because I want to go on not to problem B yet, but to problem C. Now, this one says, go find the function f and put f of 3 into it. Well, wait a second. F of 3, wait a second. What does f of 3 mean? So let me do this. What is just f of 3? What is just the inside part? Go find function f and put a 3 into it. Isn't that 3 over 3 plus 3? You're not going to cancel those 3's, right? So f of 3 is the same thing as 1/2. So problem C says, go find function f and put f of 3 into it. But you found what f of 3 is. So now go back to the function f you see what I did there? You see what I did there? I rewrote 3 as 6 over 2. Isn't 6 over 2 the same as 3? Hello. Don't you dare cancel those 1/2. You don't have factors. What is 1 over 2 plus 6 over 2? Here's our fraction within a fraction, so you're going to use our division rule, right? Definition of division. Division is multiplication of the reciprocal. Now you do have multiplication. 2 divided by 2 is 1. And your answer is 1/7. Now I'm going to go and do problem B. Because problem B is the exact same process as C. It is composition, but it's composition with a number, so I don't get a function. I'm going to get a number as an answer, but they've used different notation. This F open circle H means this. Right? It means put H into F, so I use it this way. So, work inside out. There's H of -2. What does that say to do? So just do the highlighted part.
Cool.
H of -2 means go find H. That's function 3. Ignore the F, ignore the red part. Just do this highlighted part. H of -2 means go to H. And plug in -2. -2 squared is 4. 4 plus 5 is 9. I'm not done yet. This H of -2 is 9. So go replace the H of -2 with 9. So the original problem said, what is F of H of -2? But H of -2 is 9. And what does that tell you to do? Go find the function F and put 9 into it. Don't you dare cancel the 9s, you don't have multiplication. And again, 9 over 12 is a fine answer. It just won't be in multiple choice. There is a common factor of 3. I'll write it out just to be. Because you have multiplication, do you see the difference? You have an addition, you cannot cancel the 9s, but you have multiplication, I can cancel the 3s. 9 over 12 is the same as 3 over 4. Crazy. All right, so I'm going to go all the way, so composition. I did a composition problem with a function, and I did 2 compositions with different notation of answers, right? But it always involves taking the inside function, whether it's a number or a function, and putting it inside another one, okay? Taking H, this time just taking H when it's equal, H of -2, and putting it inside the function F. I couldn't, here I had to just put the entire g of x in there. It didn't tell me a number, right? But I'm going to erase all of this because I want to go cycle back to A, and then notice I haven't done D at all because it's a completely different type of problem. So, going back to this problem, remember this is really an F in front of there. On my list of worries, another thing is making sure you know how to do domain and range. Something you've been doing since pre-algebra. It is important. So, domain and range, here are the things that you need to worry about for domain and range. You always have to worry about,
So Dean, you said
do
the
you have a
405
function
turns
that
to the
allows
73.
that has the possibility of maybe
73 is that
division by 0?
405 just hits it.
That's
405,
bad.
It will with you doing
It's
nothing.
trying to send me that one.
Yeah, don't
Do you have a
bother with it.
function
Unless
that
it's
allows
saying
you the
it's way
possibility
faster,
of a
but I can't
square
imagine what it is.
No.
of a negative? That's bad,
So you're just gonna stay on 405.
Yep. I love it.
okay?
You won't even notice
Those
it.
are your 2 main There are others. The other one is, do you have a log? Where your base is negative, or a log where the argument is negative. Those are also worries. And then of course you have trig worries. And your trig worries are tangent, secant, cosecant, and cotangent. All of these things that make me sad involve when I've got numbers I'm not allowed to plug in. Right? So when you look at function f, right away you need to know, hey, you know what? I am never allowed to plug in -3. Why? It would mean division by 0. Bad. Look at g. I can never plug in a number that is what? If you put in 3 for x, 3 minus 3 is 0, is it not? Right? Square root of 0 is 0. That's okay. I just can't have a square root of a negative. So what happens if I put in a number smaller than 3? Right? X has to be greater than or equal to 3 in G. Because if you put any number in smaller than 3, you're going to get the square root of a negative, which is bad. Now look at H. If you put any number in and square it and add 5, are you going to get division by 0? No. Are you going to get a square root? No. Are you going to get anything to do with logs? No. Are you going to get any trig issues? No, because there's no trig. Right? Polynomials are my faves. Right? So what happens? How do I get division? I have to have a fraction. How do I get the radical of a negative? I gotta have a radical. How do I have logs with bad bases or logs with bad numbers? If I have logs. How do I have domain and range worries with trig? If I've got tangent, secant, cosecant, and cotangent. I ain't got any of those situations here. Matter of fact, I don't have any of those situations with any polynomial, and I don't have any of those situations with sine or cosine. Love, love, love. Right? All right. So, why do I care about this? Why am I even talking about this? Well, because notice h, the function h we love, right? I got no worries with h, but look at g. G has some problems. So, remember when we did all this work and we simplified? We got x plus 2. X plus 2 ain't trig, ain't logs, ain't radicals, and there's no division in it. This looks like I have no domain issues. But you used a function that had domain problems. So you are responsible for saying, by the way, x has to be greater than or equal to 3 here as well. That's fine print. On your list of worries is domain and range. You do have to remember these, but in this context, it's not going to be a huge deal if you forget when you're doing composition to list the domain and range. It's more important that you actually know what causes domain problems, but it's not bad for you to remember. It will help you, right? And sometimes if you forget, it will cause problems, but it's not a major problem. All right. Problem D is completely different from all of these. All of these are composition problems. This is asking you for inverse. inverse of a function. The inverse of a function is when you switch domain and range. So, here's what I mean by that. G of x was the square root of x minus 3. And don't forget, x has to be greater than or equal to 3, right? You can't take the square root of negatives. If you put a 2 in for x, you get the square root of negative 1. Now, if you're, at some point in Algebra 2 or Pre-Cal, you were taught about imaginary numbers and, set of complex and all that. In calculus, and in any math, SAT, APs, IB test, the set you're working with is real numbers. Don't go off into the set of imaginary numbers unless someone tells you to, and nobody told me to. So if I can take the square root of negatives if I go out of the set of real numbers, but you're not going there. You're in the set of real numbers. So don't forget that another name for these are the answers, or the range. I can call the range y. Right? Y gives me the range Y are your answers. Your answers are your ranges. X is what you're choosing. That's your domain. Right? So I want to switch the domain and range. That's what the inverse is asking me to do. Switch the domain and range. So in place of the range, put the domain. In place of the domain, put the range. You've done the inverse. Have you done? Except that this answer won't be in multiple choice. In multiple choice, you need to get y by itself, right? So you need to do the order of operations backwards, which means, right, you get rid of, right, all addition and subtraction outside the grouping. Right? I want to get y by itself. Well, I have to get rid of the grouping first, so what do I have to do? Square the square root. Ugh. There's no multiplication or division to get rid of. Get rid of addition and subtraction. I'm going to write that in kind of put my y over here, just so we're looking. Usually we look at the range. Now, this y is the inverse. The inverse of who? It was, we started with the function g, right? So I can say that was g, but remember I switched the domain and range, so you use that -1 symbol. And now I have the inverse in the correct notation, but don't forget, you had an issue here. X has to be greater than or equal to 3. Right? Was the domain. Where did that come from? What is going on? All right. Let me do a little background information. The original function g of x is a function where the first number you're allowed to put in is 3. When x is 3, y is 0, right? What happens when I put in, let's see, 7, when x is 7? When x is 7, 7 minus 3 is 4, square root of 4 is 2, right? And so on and so forth. So g of x is equal to square root of x minus 3. This is what the graph looks like. When you plug in numbers for x, you get this, right? Half of a sideways parabola. When you switch x and y, when you switch the domain and range, you're going to take this, and I claim that you get x squared plus 3. When x is 0, y is 3. When x is 1, y is 4. That's the inverse function. And some of you might remember that inverse graphs are reflected across the line y equals x. Remember? Right? Now look at my blue graph and my purple graph. Can you flip them around there? This is the line that my yellow line is y is equal to x, right? Y is equal to x is a straight line 45 degrees through the origin. Notice what y equals x says. Range is turned into domain. Switch x and y. Switch domain and range. Well, look at my purple graph. My purple graph, and this is why on your list of worries, domain and range. The domain of your purple graph is x is greater than or equal to 3. The range is y is greater than or equal to 0, right? The lowest y value I use is 0. To do the inverse, you need to switch the domain and range. So the domain of g was x is greater than or equal to 3, and its range was y is greater than or equal to 0. So the domain of the blue graph is the old range. Right? Old range. Old range is new domain. Old domain is new range. And that's why in my inverse, x has to be greater than or equal 0 for the new domain. Now, I don't want to freak you out. This extra domain piece to the composition problem and this extra domain piece to the inverse problem is icing on the cake. It's important. It will trip you up if you don't remember it sometimes, but it is way more important on your list of worries to know how to do a composition and how to find domain and range. And then again, icing on the cake is, can you do that? Can you figure out the extra little twist with after you do composition, after you do inverse? Can you figure that out? That is not a make or break. I'm going to fail calculus if I don't understand those two tricky little pieces. Okay? So while I did want to expose them to you, I do want to do it. Did want to do it with you. I don't want you to freak out if it is seems a little confusing, okay? The actual finding domain and range, actually doing composition, knowing log properties, right? Factoring, fractions, exponent rules, log rules, domain and range, how to do a composition. Those are basic skills that I need you to be good at coming into my class next year. All right, that's it for this day. I will have some supplementary practice for you on our class page, and I will